2.4 is going to discuss similarity and transformations a little bit more, okay? A similarity transformation is when a dilation follows a rigid motion. What are my rigid motions? Translation, rotation, and reflection.
I was thinking of translation.
You're late. Okay. So it's when a dilation follows a rigid motion. Is a dilation a rigid motion?
Yes.
No. Because when you have a dilation, something gets smaller or larger, which changes the side lengths, correct?
Yes.
And rigid motions happen when this object stays the same. So a composition of transformations is what we're going to talk about today. Composition, more than one thing happening, okay? So here, we have a lot of stuff going on. What does it look like is happening first here? We start here in this blue one, and we go to the green. What do you think is happening?
Translation.
What did you think happens, Carlin? It does look like it's shifting over. Okay? It looks like it's shifting over. It's at -6, -2. So how many units is that? 1, 2, 3, 4, 1, 2, 3, 4, 5, right? 5 units.
Yes.
This one starts at -1 and is at 3. So 1, 2, 3, 4, 5. So this is 5 units. So what type of thing happened? You said a translation? Okay, so a translation happened. If point A went from -6 and it's now at -1, what was the translation that took place? How many units did it translate by?
Shouldn't it be 4?
What?
Like units. And not 5?
1, 2, 3, 4, 5.
Oh, I counted 5.
What did it translate over by? If it starts at -6 and goes to -1. How many? 5 to the right. So I have +5 on the x, right? So the first thing that happened was x has +5, y had +0, right? That's how I would say that technically. Okay? So the first thing that happened was a translation or a slide, a translation of 5 units to the right. Now, what happens if I go from green to this purple one? A reflection? Okay, what type of reflection? Reflection over the x-axis?
Yes.
I believe that's correct. Let's double check. Is it the same units away? Here it is 1 unit away, and here it is. Is it 1 unit? No, it's 1 unit, and it's 1 unit. Yep, you are correct. And then what happens from purple to this? I think it's red. What happens from purple to red? Yeah, some type of factor. What's that? What type is that? What is that called? No, it's not space. What's a scale factor? A scale factor.
Space.
So a scale factor happened. What type of scale factor do you think happened? If we know that this is 5 units long, right? And now this one is at 1.5 and 4.5. So 1.5. So that's 1, 2, 3, 4, 5, 6, 7 units. And it was 5. What happened? Ooh, that's a tricky one, isn't it? If it was 5 units, and now it's 7 units, what happened? Did we multiply by a whole number or by a fraction? A whole number. Why do we know that? Because it gets larger. Okay, so let's take a look at what happened. So that's the first one, you got it right. It added 5 to x. The second one is it takes the opposite of the y coordinates. It's a reflection about the x-axis. The dilation, however, is 1.5. If you take 5 and multiply it by 1.5, what do you get? Carly's.
Wait, what?
Take 5 and multiply it by 1 point.
Oh, multiply.
7.5. Is this 7.5 units long is what we have to figure out. It starts at -1.5 and it ends at positive 4.5, right? 1, 2, 3, 4, 5, yeah, so it's translated by 1.5 units. Okay, if all three, this is important to know right here, all three transformations are rigid motions, then the result is both a congruent and a similar figure. Okay, if all three transformations are rigid motion, then the result is both a congruent and a similar figure. Which makes sense, because rigid motions are congruent, and they also are similar, okay? So if all three transformations are rigid motion, then the result is both a congruent and a similar figure. This section is basically just combining everything you learned into one little area. Makes life so much more convenient.
Are those pineapples on your shirt?
They are
Did you buy that just for this day, or have you had that?
no, but I got it for free, so it
Wow.
doesn't really matter. Okay, so then you have this. This is the composition of transformation. It says the point 410, okay? The point 410 is the upper vertex of a triangle. The triangle is reflected about the y-axis, dilated by a factor of 2 with the origin as the center of dilation, and then translated up 5 units. What are the final coordinates of the vertex? So let's take this step by step. The first thing says, it is reflected about the y-axis. So what happens when I reflect that over the y-axis? What does that point become? Instead of 410, what does it become? Negative 410. So my triangle now is going to be facing something like this, right? And this is negative 410. So that was the first part that we did right there, okay? We went ahead and we reflected it over the y-axis. Okay, so you get negative 410. You were correct. Okay, the second part says, now it is dilated by a factor of 2 with the origin as the center. So what does that mean happens there? It gets what? Okay, so what's my new point? It is dilated by a factor of 2 with the origin as the center of dilation. So if it gets twice as big, what does that mean my new point is? What do you think it is? You want to say negative 820? Okay, so let's see if negative 820 is our next point. Yes, our next point is negative 820. Okay, and then it is translated up 5. So what does that become? Negative 825. So that means I'm adding to the y-axis. So your final point is negative 825. Okay, what are the final coordinates of this vertex? So if you break it down and take it one step at a time, can you handle that?
Yes.
Okay, just do it one thing at a time. And then if you have to work backwards, you're going to reverse it one at a time. So if it said, here's its final point, what was its original point? And they tell you that order, you have to work backwards. You would have to subtract 5 first. You then have to divide by 2. And then you'd have to reflect it back. Okay, you have to be able to go back and forth between the two of those. Last thing. A transformation changes the size of a figure, but maintains its shape. The transformation must be a form of a rigid motion. It must be a dilation. It could be a rigid motion transformation or dilation, or it cannot be a rigid motion transformation or dilation. Which of those statements best fits that? A transformation changes the size of a figure but maintains its shape. The transformation is what? What changes the size but keeps the same shape? What else? A dilation, yeah. So it's B. It must be a dilation because it changes the size of it, but it keeps the same shape as my original figure. That's what you're doing tonight. You're combining all of those elements together into one thing. Cool?